Hi everyone. So in this video I'm going to basically do problems that involve kinetic energy. So let's recall that kinetic energy has this form of a half mv squared, and so let's begin. So if I'm ever asked about the kinetic energy of a car whose mass is 1500 kilograms and goes by 10 meters per second, then the kinetic energy of this car would be a half mv squared, as the kinetic energy formula is. And then that turns out to be a half 1500 times 10 squared, and that gives me 750 and then 2 zeros. And it's in joules. So this is basically this big number. 75,000 joules is the kinetic energy of a car whose mass is 1500 kilograms and goes by 10 meters per second. So this is one of the simplest question about kinetic energy, the most routine one. So now let's just keep going with these problems. Well, it says there is a baseball whose mass is 450 grams, so be careful. So the mass of the baseball is 450 grams, and it's at rest first, and I give it velocity of 25 meters per second after I hit it with force of 10 newtons. How far does the baseball go? So here's the scenario. Always draw the question. So there is this ball. It's first at rest. Now I exert some force on the ball of 10 newtons, and I give it speed of 25 meters per second, and I make it actually move. And I was just wondering, I'm wondering how far it'll go if this is the story. So I know that it was initially velocity was 0. Now it has some velocity, and it's asking about distance. So if it was asking about time, then it would be change in momentum, because change in momentum deals with force and the time that the force during which the force is exerted on the object. However, change in kinetic energy is force times displacement of the force, right? So the first kinetic energy is 0 because it's at rest. So KE1 is 0. Now I'll give it some velocity, so it actually earns some kinetic energy. So the change in kinetic energy is kinetic energy second minus kinetic energy first, and that's F times the displacement. So the second kinetic energy is for the kinetic energy of the ball when it has this velocity. Kinetic energy has this formula of a half mv squared. For this one is 0, just because the velocity is 0. And my force is 10 newtons. And then I'm solving for the displacement of the ball as I hit it. So let's plug things into the formula for kinetic energy. It's essentially a half times the mass. The mass is 450 grams. So grams smaller, kilograms are bigger. So 450 grams divided by 1,000. That gives me the kilograms, V squared, and I know V is 25 meters per second, so 25 squared, and that minus 0 gives me 10 times D. So 10 times D. So we'll do the math here first. So that gives me, this gives me 625 divided by 2 and then multiplied by 0.45, and that gives me 140.625, and that's equal to 10D. Now I want to isolate my D, so I better divide both sides by 10 so that I can get rid of the 10 here. So D equals 14.06 meters. So it's actually a very realistic question. So if the ball is 450 grams and it's initially at rest, if I hit it with 10 newtons and I give it 25 meters per second of velocity, how far does the baseball go? I know I'm looking for how far, which means which means the displacement. And I know I have the mass and I have the velocity, so I know the changing kinetic energy is force times displacement, which is essentially the work done by my force, in other words. And the changing kinetic energy is kinetic energy second minus first. That gives me F times D. I just plug things in, and you'll see how we end up with the answer. That is 14.06 meters. So this is another question that deals with kinetic energy and basically forces and displacement, which is force times displacement is work. The other kind of kinetic energy questions would be the fact that, there are like collision problems, and you have before and after collisions and stuff like that. So let's just do those problems a little bit together. So I'm having these billiard balls, and one of them, the one ball is about 200 grams, and it's going by 5 meters per second, and the other is actually at rest. And this one is 300 grams, and this one hits the ball, and then it starts moving by 4 meters per second. This guy starts moving, so this one hits this one, which makes it move to the right by 4 meters per second, and this guy basically stops after the collision. I'm just wondering if my kinetic energy is conserved, and if it is not conserved, then how much is the loss in my kinetic energy? So this is before the collision, and this is after the collision. So kinetic energy of my whole system of two balls before the collision is combination of both of them. It's kinetic energy of this plus the kinetic energy of this one. So it's a half m 200 over 1,000 to give me kilograms v squared plus a half m v squared. So this is dead zero already. So whatever I have kinetic energy before for my whole system, then let's just figure it out. So that gives me 100. That cancels out. That gives you 2.5 joules of energy before the collision for the whole system. And now let's work out the kinetic energy afterwards for the whole system. So kinetic energy after the collision for the whole system reads kinetic energy of this guy, because this is after the collision, it stops, and then this is kinetic energy afterwards. So a half m, which was 200 grams, v squared, so that's already 0, plus a half m, that was 300, v 4 squared, see, it was 4, and then I end up with kinetic energy afterwards to be 16 times 3 divided by 20, that's 2.4 joules. And see, I first started by 2.5, I ended up by 2.4. So I have a kinetic energy loss of 0.1 joules. This minus that gives me the loss. So this is not conservation of kinetic energy. In this collision, my kinetic energy was slightly lost.